Welcome friends. Today's topic is work done in multi-stage compressor. Multi-stage compressor with the intercooler, which means multi-stage compressor means, remember the steam power cycle, reheating cycle. Remember this steam power reheating cycle in Rankine cycle. Which is, there we have HP turbine, LP turbine. In between these two, we have reheater. Okay, because reheat, the purpose of reheater is to heat the exhaust steam from high pressure steam and supply to the low pressure turbine. But here also same concept, because in single compression we can't enough to compress very higher pressure, because during compression process temperature rises. Okay, during compression process temperature rises because pressure is directly proportional to temperature, and even if temperature rises, density also decreases. Okay, therefore if density decreases, mass flow rate or discharge is decreases. Even though high pressure is achieved, but mass flow rate or discharge is affected, which means enough amount of air is not delivered from the compressor due to the higher temperature, because the temperature rises, the air occupied volume also increases. Therefore, volume increases, but mass of the actual gas is decreases. Therefore, the temperature is major role. Okay, therefore, in single compression, temperature gets rise a very high value. Therefore, at that higher value, density value decreases due to the decrease of the density. The discharge effect, actual mass flow rate of the volumetric efficiency decreases, and also mass flow rate is affected. Therefore, to eliminate this loss, we introduce multi-stage compression, which means HP turbine, like HP turbine, LP turbine. Here, LP cylinder, HP cylinder, two compressors. You also see puncture shops and many petrol pumps. They are having multi-stage compressors. In that heat type compressor, heat type, in between the heat type compressor, one tube is there. This one, and this is one. Compressor is like this. Here the connector is there. The connector is having some things. This is called intercooler. First is here LP cylinder. This is HP cylinder. It is connected with tank. It is connected with atmospheric air. And first the atmospheric air is sucked by LP cylinder, and this compression takes place. During the compression, pressure increases. At the same time, temperature increases, and it passes to the intercooling unit. That intercooler cool the temperature alone. Okay, then it passes to the HP cylinder. Again, air is compressed and is passed to the storage tank. Okay, through this compression, the mass flow rate, discharge of the compressor is not affected. Okay, and high pressure compressed air also achieved. Okay, high pressure of the compression is also achieved. This is the advantage of the multi-stage compressor. See the PV diagram. The first one is first stage compressor, and second stage compressor. Okay, 1, 2, 3, 4 is LP compressor, and is then passed to the HP compressor. This 2, 5, 6, 7, 8. 5, 6, 7, 8 is the second stage compressor. Okay, which is the multi-stage compressor. So here we have two compressors. In between the two compressors, we attached one part which is called intercooler. Okay. You also seen saw many vehicles. For example, Tata 407 and Eicher vehicles. In front panel, they are writing on that with the turbo intercooler, which means that engine having turbocharger and also intercooler. Turbocharger is different concept, and intercooler is different concept. Okay, but the intercooler they are mentioning is that. Okay, Then now we start the derivation. Here they are clearly mentioning the two-stage compression process. First stage compressor and first initially air at P1 and T1, and first stage compression takes place. Then the air temperature is raised at to T2 and air pressure has rise up to P2. Then it is passed to the intercooler section. Then temperature is reduced and then passes to the HP cylinder. Then temperature and pressure is rise up to P3 and T2. This is the concept of two-stage compression. Okay. Then the PV and TS diagram is PV diagram is like this, two-stage compression. This is the two integration of two PV diagrams. Okay, two PV diagrams. Integration. Then isentropic relation is T2 by T1 equal to P2 by P1 power n minus 1 by n. Then total indicated work. The total indicated work equal to work input equal to work LP plus work H. Then we know work LP equal to what? N by n minus 1 P1 V1 minus P1 into V1 minus with clearance, with considering clearance. Okay, then P2 by P1 power n minus 1 by n minus 1. Then plus HP is the same formula, but the limits are very different. Then P1 into V5 by V5 minus V8 and P3 by P2 power n minus 1 by n. Okay, two different pressure ratios. Then in terms of mass of air inducted per cycle, n by n minus 1 m. P in terms of P, instead of PV, we substitute MA. MA RT1 into P2 by P1 by n minus 1 by n minus 1. The MA RT1 P3 by P2 by n minus 1 by n minus 1. Then WN equal to n by n minus 1 is common from both places, and MRT1 is also common. Therefore, you can take the n by n minus 1 and MRT1 from the bracket, then we get a work input equal to n by n minus 1 into MART1 power bracket P2 by P1 n minus 1 plus P3 by P2 n minus 1 minus 1 minus 1 added, then minus 2. Okay, this is the exact formula for two-stage compression. If three-stage means MRT and another pressure ratio term is added and minus 3, and four-stage minus 4. Likewise in increases. Okay. MA equal to PF into VF divided by RTF. Then equal to P1 into V1 minus V4 divided by RT1. This is equal to P2 equal to P5 V8 divided by RT1. Okay. So mass flow rate is same throughout the it tells mass flow rate is same throughout the HP and LP cylinder. Both are having same mass flow rate, and only I can substitute MA RT1 instead of P1 V1 P1 into V1 minus V4 and P2 into V2 minus V4, because through the both calculations having same giving same mass flow rate. Okay, therefore I can write the equation like this, because in previous formula that work done is equal to V1 minus V4 and V5 minus V8. This is the form of subtractant formula, but here I write only MRT1. So where is the V1 minus V4? Where is the calculation, or where is the conversion, or conversion from V1 minus V4 to that temperature? It is like this. MA is calculated through this terms. Here this term is different, but the ratio between these, so the calculation from substituting these values, the mass flow rate is same, because steady flow energy analysis SFE. So therefore, I can convert the P1 into V1 minus V4 into MART through with the help of this relation. Okay. Then indicated power equal to n by n minus 1 MR mass flow rate. Okay, mass flow rate. There mass flow. Here indicated power in terms of m dot. So only different. P2 by P1 n minus 1 by n plus P3 by P1 n minus 1 by n minus 2. Likewise, if we increase the number of stages, that pressure ratio is increases, and number minus 2 minus 3 also increases. Okay, this is one type. Then next, condition for minimum compression work. Next topic, condition for minimum compressor work. Main important derivation. Condition for minimum compression work, optimum intermediate pressure. Okay, minimum compression means how we reduce the input energy for both the compression. Okay, what is the stage? Likewise, maximum discharge in nozzle. We have one condition. Okay, likewise here also one condition to reduce the work input for both compressors. Okay, then intermediate temperature P2 is influence the major role, because the P1 is inlet temperature and P2 is applied to the intercooler, and then the P2 and then exit from the intercooler is again supplied to the HP turbine, the HP compressor, then by again the compressor compresses and deliver the pressure at P3 and T3. Okay, therefore the intermediate temperature P2 plays a vital role in a compression process. Okay, LP cylinder, this HP cylinder. HP is LP. So that P2 and P3 plays a vital role. Okay, these lines are common. This line only is a common line for this line is the common line for this line is a common line for this line. This line is common line for both HP and LP cylinder. Okay, for P2 equal to P3. P2 equal to P3. This is therefore the pressure is major role, plays a major role for the both LP and HP cylinders. Okay, therefore one clue. Indicator power equal to n by n minus 1 MA RT1 P2 by P1 power n minus 1 and P3 by P2 power n minus 1 by n minus 2. For max, for minimum work input, the D indicated power by dP2, because P2 is main important parameter. Therefore, P2 is a differentiable value is equal to 0. Consider the concept. Then n by n minus 1 MA RT1 D of dP2 and P2 by P1 n minus 1 by n plus P2 by P1 n minus 1 by n minus 2 equal to 0. Then n by n minus 1 MRT1 those are the constant values. Therefore, I can eliminate. I only consider this one. Only consider this part alone. Okay. Then P1 also constant. Therefore, I can take the value 1 by P1 into n minus 1 by n and d by dP2 or P2 power n minus 1 by P2 power n minus 1 by n plus P3 power n minus 1 by n into dP2 by P2 power 1 minus 1 by n. Okay, because B2 and P3 are constants, P2 only a variable. Therefore, P1 and P2 is taken for the differentiation and consider P2 is alone for differentiation. Therefore, in first part P2 is numerator, therefore P2 power n minus 1 is directly written, and in second part P2 is denominator, therefore P2 power 1 minus n by n, because from numerator denominator to denominator the conversion factor is minus in power, therefore 1 minus n by n is equal to 0. Therefore 1 by P1 power n minus 1 by n into the differentiation is n minus 1 by n into P2 power n minus 1 by n minus 1. And second differentiation plus P3 into P3 power n minus 1 by n into the differentiation term is 1 minus n by n into p to power 1 minus n by n minus 1, because x power n equal to x power n minus 1 by n into x power n minus 1. Here the place is p2 power n minus 1 by n. Therefore, n minus 1 by n into p2 power n minus 1 by n power n. Okay, the n term is here is n minus 1 by n, and second term is 1 minus n by n. Okay, therefore, using the same differentiation formula, then we get the relation like this. Then simplification is only the balance simplification process. 1 by p1 1 by p1 power n minus 1 by n, p2 minus 1 by n, minus p3 into n minus 1 by n into p2 power 1 minus 2n by n equal to 0. And small calculations. Then p1 is numerator 1 minus n by n, p2 power minus 1 by n, which is equal to p3 power n minus 1 by n, p2 into 1 minus 2n by n. Then p2 equal to p2, then this p2, then p2 power minus 1 by n plus 2n by n minus 2n minus 2n power 2n minus 1 by n, which is equal to p1 n minus 1 by n into p3 n minus 1 by n. Okay, small rearrangement from LHS and RHS. Okay, then p2 power 2 n minus 1 by n, which is equal to p1 by p3 power n minus 1 by n. Small rearrangement, then n minus 1 by n minus 1 by n cancel, then p2 square equal to p1 p2, p1 by p3, p1 p3. It is from p1 p2 by p1, which is equal to p3. It is a perfect interpol. It is called the perfect interpol. p2 by p1, which is equal to p3 by p2, or p2 square equal to p1 by p2, or p2 equal to square root of p1 by p2. It is the condition for minimum compression work. It is the condition for minimum compression. For reciprocating air compressor, minimum compression work, the condition is P2 equal to square root of P1 by P3, so P1 and P3, or P2 by P1 equal to P3 by P2. Then remember this concept. And condition for multi-stage compression, P2 by P1 equal to P3 by P2 and P4 by P3, and etc. etc. So we increase the compression stage of compression, and it leads the series of pressure ratios. Okay, but pressure ratio for perfect intercooling or minimum work input, all pressure ratios of all stage of compression is same. Okay, this is the concept. Okay, and P into Z plus 1 by P Z is equal to X. Same. This is the condition for minimum work output in a particular two-stage compression. If we raise the compressor, one more additional compressor cylinder, that work input formula having slightly changes, which is additional one more pressure ratio portion, and the minus 2 instead of minus, say, minus 3 instead of minus 2 for three-stage compression. Okay, and similarly for imperfect intercooling, that relation is P2, that intermediate pressure is in terms of P multiplication of P1 and P3. Okay, P2 square equal to P1 and P3. This is a perfect intercooling, which means for every stages of compression, the pressure ratio is same, which is the concept. The pressure ratio is same. If we create the same pressure ratio and for all all stages of the multi-stage compression, then we supply enough amount of work. Okay, otherwise the energy input is very high. Okay, for minimum work input, the pressure ratio is same for all stages of compression. Okay, within this topic I conclude the 5th unit. Remaining topics are self-studied by you. Okay, thank you.